Welcome to this interesting question. Given to us is a semicircle and a circle inside a bigger semicircle with radius 3 centimeter. The radius of this smaller semicircle, that's 2 centimeter. Exciting part is with this limited data we have to find the radius of circle. Today we'll discuss the general approach for solving such questions. So here three circles are given to us. So we'll apply all the theorems related to circles and do all the constructions and detect all the values which are possible. Now here we'll see that AB is a tangent with respect to this blue and purple circle. So from point P, if we'll join the point of tangent C, we know that it's perpendicular to the tangent. PE is the radius, so it's 2 centimeter. Same way from point Q, when we join point of tangent C, it's perpendicular, and QF is radius, that's let's say r centimeter. Also the second theorem we'll use is when two circles are touching each other, then their centers and point of contact lies in a straight line. So here one is this brown and purple circle, they are touching each other, so their centers OQ and point of contact lies in a straight line. Now here QG length, that's your r centimeter, and thus OG is full 3 centimeter for the brown circle, so OQ length will be 3 minus r. We can apply same theorem on this blue and purple circle which are touching each other, so their centers and point of contact lies in a straight line, and PQ length, that will be your radius of blue circle plus purple circle, or 2 plus r centimeter. Now what other theorem we can apply here? If we'll see CD is a chord with respect to brown circle, and P is the center of that chord, and we know that perpendicular bisector of any chord passes through the center of circle. So perpendicular bisector of CD will pass through point O. Now what is the length of PO? So that we have to find. If we'll see, this is a right angle triangle is formed. So this right angle will use by joining length OD. OD is the radius of brown circle, so it's 3 centimeter. Now in triangle OPD, applying Pythagoras theorem, OP length, that will be square root of 3 square minus 2 square, or square root of 5. Again in triangle PEO, applying Pythagoras theorem, EO length, that will be square root of 5 minus 4, or 1 centimeter. And in triangle OQF, applying Pythagoras theorem, so we'll get OF as square root of 9 minus 6r. Now we have to form equation in terms of r. So for that we need a triangle where all the sides are in terms of r. So for same, from point Q, let's drop a perpendicular on PE. Now here in triangle QHP, HQ length, that will be 1 plus square root of 9 minus 6r, and HE length, that will be same as QF or r centimeter, and thus PH length, that will be full length 2 minus r. So we have got our right angle triangle where sides are in terms of r. Applying Pythagoras theorem, we'll get this equation. Solving it, applying a minus b whole square here, we'll get this term. Second term, applying a plus b whole square, and the term on RHS, again applying a plus b whole square. So simplifying it, both the side 4 and r square will get cancelled down. Now to solve it further, we need to get rid of this square root. So for that, let's take square root on LHS and all other terms on RHS. So we'll get equation in this form. Now simplifying it, so we'll divide full equation by 2 to get this as new equation. Now to get rid of square root, let's do square on both sides. So LHS will become 9 minus 6r, and RHS, applying a minus b whole square identity. Now taking all the terms on LHS and simplifying it, we'll get a quadratic in terms of r. Solving this quadratic by applying quadratic formula, we'll get value of r as this, which on simplification will get r as 32 plus minus 4 root 15 by 49, which in decimal form will be 0.97 or 0.34. But 0.34, when we put this value in this right angle triangle, we'll get HQ length is getting bigger than PQ length, which is not possible. So 0.34 is a wrong answer, and thus R is 0.97 centimeter. I hope you enjoyed the solution. I will see you in next video. Till then, tata, bye bye.